used with ductile material is called Coulomb-Mohr theory. In ductile material, we usually have one strength that is reported. Yield strength, one yield strength that's reported. And that indicates that yield strength for tension is equal to yield strength for compression. And that's the case for most of ductile material. But there are few ductile materials that has yield strength and compression larger than yield strength and tension. Or in other words, yield strength and tension doesn't equal yield strength and compression. So in this case, two yield strengths are reported. So if you look at the tables, you'll see yield strength and tension and yield strength and compression. So in this case, you can use Coulomb-Mohr theory. For this theory, this theory can be found by using tension only test and compression only test. So you see that tension strength is much smaller than compression strength. Okay, so this is the formula for Coulomb-Mohr theory. This formula. So if you look at the formula, you see that you need to compare your positive stress, this is the largest stress, usually positive, with your strength and tension, and smallest stress or negative stress with your compression strength. And you need also to include a factor of safety. So let's look at the three cases, because sometimes you only have tension, sometimes only have compression, sometimes you have both tension and compression. So for the first case, when there is no compression, in case 1, you see your two principal stresses. When you calculate the two principal stresses, you get two positive values. So in case 1, there is no compression, so there is no need. You see, there's no compression, so sigma 3 is 0, or smallest sigma is 0. There is no need to compare your compression stress with compression strength, because there's no compression stress. So only use sigma A with this formula. In case 2, you need to use both, because in case 2, you have positive stress and negative stress. So you have tension and you have compression. You need to compare both tension stress with tensile strength, compression stress with compression strength. In case 3, we don't have tension. Here both stresses are negative. So we only use the smallest stress, which is the largest negative value here. There's no need to compare tension in this case. Okay, so this is the safe envelope for Coulomb-Mohr. You see tensile strength is less than compression strength. Any point outside this envelope means we are not safe and failure is expected. It's similar to maximum shear stress, except with different strengths. Okay, now this case when we have only shear. There is no tension, compression, no bending, only pure shear loading, only torsion and shear stress. So in this case, you can calculate yield strength for shear from both strengths, compression and tension. So the tension and compression strengths will give you yield strength for shear. We compare this yield strength for shear with the applied shear stress. If my applied shear stress is larger than larger than yield strength for shear, then we expect failure. So shear stress must always be less than yield strength for shear in order to have safe design.